You're outside right now. Maybe you're walking to your car. Maybe you're sitting on a bench. Maybe you just glanced up at the sky for half a second without thinking about it. The sun is there. It's always there. It has been there every single day of your life, every single day of your parents' lives, every single day of every human who has ever existed. And right now, in this exact moment, it's gone. Not dimming, not exploding, just gone, vanished, as if it was never there. Here's the part that should unsettle you. You don't know yet. Nobody does. The light hitting your face right now left the sun 8 minutes and 20 seconds ago. That's how long it takes for sunlight to reach Earth. So for the next 8 minutes, everything looks exactly the same. The sky is still blue. The grass is still green. Your shadow is still behind you. And somewhere, 93 million miles away, there is nothing where a star used to be. This is what the next few hours, days, and years would actually look like. And by the end of this, you will never look at the sky the same way again. Let's start the clock. T-0. The sun disappears. For exactly 8 minutes and 20 seconds, nothing changes. Birds keep flying. Traffic keeps moving. Someone somewhere is complaining about it being too hot. The last photons of sunlight are already in transit, racing toward us at 186,000 miles per second. They left a star that no longer exists, and they don't know that yet. Then, minute 8 arrives. The sky doesn't go dark like flipping a switch. It goes dark the way a candle goes out in a storm. The blue drains first, then the orange at the edges, then the last thin line of light at the horizon. And then, nothing. Full darkness, in the middle of the day. Your first instinct is that something is wrong with your eyes. Your second instinct is to look for your phone. Meanwhile, every solar panel on Earth stops producing power simultaneously. Billions of devices relying on solar energy cut out in the same instant. Parts of the power grid that depend on solar input begin to destabilize. But here's what most people miss in those first few minutes. It's not the darkness that kills you. It's what comes after it.
The Earth holds heat. That's important. In the first hour after the sun disappears, the temperature doesn't crash. It drops maybe 1 or 2 degrees Fahrenheit. Uncomfortable, not lethal. You would survive the first hour in a t-shirt. But the Earth is now a spaceship with no engine and no heat source. And it is bleeding warmth into the coldest environment in the universe. Space is not cold the way a freezer is cold. Space is cold the way nothing is cold. The average temperature of deep space is minus 455 degrees Fahrenheit, nearly absolute zero. And we are now exposed to it. Without the sun, Earth's average surface temperature starts falling by roughly 1 degree Fahrenheit every hour in the first days. That sounds manageable. It is not. Because it doesn't stop.
By the end of day 1, surface temperatures have dropped between 10 and 20 degrees Fahrenheit globally. In equatorial regions, what was 85 degrees is now 65. Chilly, uncomfortable. In northern Canada, what was already cold is now deadly. By day 3, surface temperatures are averaging below freezing across most of the planet. Crops begin dying. Not because of frost alone, because photosynthesis has stopped. Every plant on Earth runs on sunlight. Without it, they are not sleeping. They are dying. Slowly, silently, in fields and forests and every backyard on the planet. By day 7, the surface of the ocean begins to freeze at the edges. Not the deep ocean, not yet, but the thin layer of water that catches sunlight every morning and feeds the entire marine food chain, that layer is gone. And here is something nobody talks about. The Earth is still moving. Right now, our planet orbits the sun at roughly 67,000 miles per hour. That orbit exists because the sun's gravity is holding us in a curved path through space. The moment the sun disappears, that gravity is gone. We don't spiral inward. We don't get pulled somewhere else. We go straight. The Earth launches itself into interstellar space in the exact direction it was traveling the moment the sun vanished. Into the dark, at 67,000 miles per hour, with no destination.
By week 2, the surface of the Earth is unlivable for most humans, without shelter and heat. Average surface temperatures have dropped below minus 40 degrees Fahrenheit. At minus 40, exposed skin gets frostbite in minutes. Vehicles don't start. Water pipes burst. Buildings that weren't designed for Arctic conditions begin to fail structurally. The food chain is collapsing from the top down. Insects die first. Then the animals that eat insects. Then the animals that eat those animals. Grocery stores run out within days, not because of hoarding alone, but because the supply chains that keep them filled depend on fuel, electricity, and functioning roads. All three are breaking down simultaneously. By month 1, the scientific consensus is this: the surface of Earth is no longer compatible with human life as we know it. But here's what that statement gets wrong.
The Earth does not die. Let me say that again. The Earth does not die. Its core, a ball of iron and nickel, roughly the size of Mars, is still producing heat. Radioactive decay deep inside the planet generates energy completely independent of anything the sun ever provided. That heat has been there since the planet formed 4.6 billion years ago. It will be there for billions of years more. And there are already humans who know exactly how to use it. Geothermal energy. Iceland runs on it today. Certain parts of the planet could theoretically sustain underground habitats heated entirely by the Earth itself. Not comfortable, not easy, but possible. A small population of humans, highly organized, highly technical, living deep underground near geothermal vents, could survive indefinitely. Without sunlight, without the surface, without the sky. But it gets stranger. Because on the floor of the ocean, right now, today, there are ecosystems that have never needed the sun. Hydrothermal vents on the deep ocean floor support entire communities of life, tube worms, crabs, bacteria, that feed on chemical energy from the Earth's interior. They have never seen sunlight. They do not need it. They are completely disconnected from the surface world that you and I depend on entirely. These ecosystems would survive the disappearance of the sun without noticing. Rogue planets. That's what they're called. Planets that were ejected from their solar systems billions of years ago, drifting through interstellar space with no star to orbit, no light, no warmth from above. We used to assume they were dead, frozen, sterile. But now we know that planetary cores stay warm for billions of years. That geothermal heat is real, and it is enough. Some scientists now estimate that rogue planets could outnumber star-orbiting planets in our galaxy by as much as 100,000 to 1. 100,000 to 1. And if even a fraction of those planets harbor life around geothermal vents on their ocean floors, the universe is far more alive than we ever imagined. And we would never be able to see it, because there's no star to find it by.
Let's come back to Earth. Everything you know exists because of one thing. A medium-sized star, made mostly of hydrogen and helium, happened to form in a quiet corner of the Milky Way 4.6 billion years ago. Not too big, not too small, not too hot, not too cold. It sits at exactly the right distance from a planet that is exactly the right size to hold an atmosphere. The margin for error is almost zero. If the Earth were 5% closer to the Sun, the oceans would have boiled away billions of years ago. If the Earth were 5% farther, they would have frozen solid and never thawed. You exist inside a window of conditions so precise that describing it as luck feels like an understatement. And every single morning, for your entire life, you have looked at the thing that makes all of it possible and thought nothing of it.
Here's where we started. You're outside. The sun is there. It has always been there. The light hitting your face right now left the sun 8 minutes and 20 seconds ago. That light crossed 93 million miles of vacuum. It passed through the atmosphere, it bent through your pupils, and landed on the back of your eye. And for one brief moment, you felt warm. You didn't think about it. You never do. That's the thing about the sun. It has kept every living thing on this planet alive for billions of years. And it will keep doing it for roughly another 5 billion. But right now, in this exact moment, it's still there. Go look at it. Not directly, obviously, but look up. And just for a second, know what you're looking at.